Hey guys, so today we are going to be going over how to identify different functions, and we do this by looking at the patterns of their y values when we're being given a set of values for a specific function. So we are going to be learning how to determine what is a linear function, a quadratic, and exponential function, and how we can determine what those are by seeing those different y values. There are a couple of different rules that I'm about to show you, but these rules only apply when the x values are separated by one value. So, for example, we're going to have a little table here. You have your x and y table, and we're going to have 5 sets. So we have our 1, so if we have 0, 1, 2, 3, and 4 for our x values. And then for our other values will be in our y. So for this set, we can do 2, 3, 4, and 5, and 6. So just for this little example here, I'll show you with another colored pen that these values here are all separated by 1. So see here, 0 plus 1 is 1. This value, the differences between these two is 1. The difference between these guys is 1. And then the differences between these guys is 1. Okay, so for the purpose of this video, I'm going to write down the next rules that are according to the different functions. So linear function, quadratic, and exponential functions. I'm going to pause this video and write it down just so it's a little bit quicker, but you pause it and then write them down in your notebook. Okay, so I'm going to have you write these definitions down, and then I'm going to go over them really quick, and then we're going to start a couple different problems for us to solve. So for a linear function, the differences with that one is if the first set of differences are all equal, the function is linear. And then for a quadratic function differences, if the first set of differences are not equal, but the second row of differences in the y values are the same, then the function is quadratic. For an exponential function differences, if the ratios of the successive y values are all equal, the function is exponential. Okay, so here are a couple of examples of different functions that we're going to work through. So we'll start with 1. So with this one, we're going to look at our y column here. And we're going to determine how many is in between these and the differences between them. So each of these guys. So the first what we're going to do is we're going to do the difference between negative 6 and 2, which is 8. And then the difference between these guys, so the second and third value, which is also 8. And then the difference between 10 and 18, 8. And then 18 and 26, which is 8. And then so per our definitions of all of the functions, this function is considered a linear function because our first row of our y values is all the same. So they're all 8. Okay, so moving on to this next one. So this one, I do have a hint with this one, but we'll go through how to do this guy first. So the difference with these guys here, so the first and second y value is 576. And then the difference between 192 and 48 is 144. And then the difference between 48 and 12 is 36. And the difference between 12 and 3 is 9. So see how all of these are not the same? We're going to do the same thing and see if there's a pattern that we can see. So with this one, there isn't a pattern here with adding. So if we did this math here, but there is a pattern if you times or multiply 9 times a number, or if we divide it as well. So if 576 divided by 44, so the ratio of it, so if we divide that, that is divisible by 4. Or if you multiply 144 by 4, you get 576. And then same with this. So if we divide 144 by 36, we're also going to get 4. And this as well. If we times 9 by 4, we get 36. Also, if you see here, which is my hint, 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. And 192 multiplied by 4 is 768. So because we're using multiplying or multiplication and division, or the ratios of these numbers together here, well, this one is considered our exponential function. Okay, so we're moving on to number 3. So we're going to do the same thing. So the differences between -5 and 15 is 10. And then our the difference between -15 and 29 is 14. And then the difference between -29 and -47 is 18. And the difference between -47 and -69 is 22. Now, so see how all of these aren't the same number? We're going to go to our next row and see the differences between these guys. So the difference between -10 and 14 is 4. Difference between 14 and 18, or -14 and -18, is also 4. And same with these guys, -4. So because of that, in our second row, so here's our first row, our second row, and so because in our second row, these guys are the differences are 4, this one is considered quadratic. Quadratic function.